Greetings and welcome to the Data Armory. We are going to look at statistics for data analysis. What are the essential statistical concepts that a data analyst needs or that are needed for an exploratory data analysis project? Josh Willis says that a data scientist is a person who is better at statistics than any programmer and better at programming than any statistics. And you find that many a times when someone gets into the data science field or when someone gets into the data analysis field, that most people will concentrate on programming and forget about statistics. And those who will think about statistics will ask the question of how much maths or how much statistics do I need as a data analyst or as a data scientist? Some will tell you that you don't need any statistics or you don't need any math. Some will tell you that you need math and you need a lot of it. But now to answer that question, at least this quotation strikes in the balance that as a data scientist, you should be a person who is better at statistics. It might not be than any other programmer, but at least you should be better at statistics. And you should also be better at programming, even if it might not be like any other statistician. So it strikes the balance and helps answer the question of, do I need statistics for data analysis or for data science? These answers that at least you need some statistics just as much as you need some programming. Now, our study objective is to know the statistics that you need for data analysis and to know some key statistical terms. Now, what is the use of statistics and as we also seek to answer what is the importance of statistics? Remember, statistics is very wide and at least we are just giving some brief essential concepts. We cannot handle all the statistics because it is very wide, but at least this roadmap will help give you the essential statistics that you need for a data analysis project or that you need for data analysis. Now, when you look at the essential use, when you look at the use of statistics, at least we'll use it to gather, review, analyze, and draw conclusions. And once it comes to mind that in your data analysis, you need to gather data, then at least that answers that you need some statistics. Once it comes to your mind that in your data analysis projects, you will need to review, to analyze and draw conclusions, at least this tells you that at least you will need to know some essential statistical concepts to help you handle these tasks. So that already tells you that anyone who will tell you that you don't need maths might not be true to you. At least you need it, or you need to know some essential concepts of data analysis, of statistics for data analysis. Now, what is the importance? Remember, we have said we're just looking at some of the foundational important reasons for statistics when it comes to data analysis. Now, the importance of statistics is that it helps to derive valuable insight, it promotes critical thinking, and it enhances critical data-driven conclusions. So those are some of the few reasons why statistics is important, and more so when it comes to the field of data analysis. So to help us do that, we'll use this mind map tool to draw out the essential statistics that we need for data analysis. What are the essential statistics that we need for data analysis? So this mind map tool will help us look at some of the essential statistical concepts for data analysis. So whenever you sit down to do some exploratory data analysis, or whenever you sit down to handle some data analysis project, then one of the most important thing that you should know is the importance of structured data, or the elements of structured data, because we know very well that when you talk about data, there are very many sources from which we get data. It can be from text, it can be from images, it can be from videos, and all these we know that they are being spewed out. They are being spewed out when they are unstructured. And we need to turn this data into structured data so that it can be of help. And that is why to apply statistical concepts, unstructured raw data must be manipulated into structured form. And that is what we are going to look at here. Some of the essential statistical concepts that you need for you, number one, to turn unstructured data into structured data, and also the statistical concepts that you need to use to explore structured data. And that's why here we are talking about structured data. Now, when you talk about structured data, there are several essential concepts that you will need. These are the essential concepts that you will need. At least you will need to know about data types. You will need to know about data types. You will need to know about rectangular data. You will need to know about estimates of location, estimates of variability, data distribution, exploring categorical and binary data, and also about correlation. So at least these are some of the statistical concepts that we have sampled in this presentation. But as we began, we say that statistics is very wide. The field is very wide, that we cannot learn everything at a go. And many a times when we learn statistics for data analysis or for data science, we take that which we need. Because if you don't have a roadmap, you will end up learning even that which you do not need, given that maths is very wide. So having mentioned this, we'll go into this and at least look at some of the things in these concepts that we need to understand. Now, when you talk about data types, one thing that we should know is that when you talk about data types, is that data types determine what you can learn or cannot learn from data. And we have handled data types here, but we do not handle data types for data analysis. When we are talking about Python, we at least handle some simple data types in Python programming language. Having an understanding of these data types is that they are important because they help you understand what you can learn or what you cannot learn from the data. Also, it's important to understand data types because it tells which data analysis, visual display, data analysis, or statistical measurements that can be done on certain data types. Because remember, there are some data analysis, there are some visual display and statistical measurements that you cannot do on certain data types. For example, if you have categorical data, there are things that you can do on numerical data, but you'll be limited when it comes to categorical data types. Now, know the best graph to visualize the data types, e.g., when you get into pandas and when you get into data analysis, or when you get into that tool that you'll be using to analyze data. Now, one thing that we should know is that when working with data, is that there are some best graphs for given data types. For example, you should know the best graph to visualize data types, e.g., for example, here we get that pie charts are good for visualizing categorical data. Pie charts are good for visualizing categorical data. So at least those are some of the few things that you need to know when you talk about data types and why it is important. Now, getting into data types, we get that there are numerical data types, e.g., continuous and discrete. And another name for numerical data types is quantitative data type, quantitative data type. Then there is also, this should be quantitative data type. Sorry for that. We have got quantitative or numerical data types, and an example of this is continuous and discrete. So at least try and have an understanding of what quantitative data types are. What is continuous data type and what is discrete data types. So continuing into this is that when we talk about data types, another thing that you should be able to know or to learn about are categorical data types. Another name for categorical data types is qualitative data types. And when we talk about categorical and quantitative data types, here we talk about binary data and ordinal data. And when we go into binary data, there's dichotomous data and indicator variable. So at least you need to have a clue on this. Now we go back to numerical data. We have talked about numerical data and categorical data. When we break it down further, under numerical data, we have talked about continuous data. Now breaking down continuous data, we see that there is what we call interval scales and ratio scales. So know about numerical data. And when you know about numerical data, you'll need to know about continuous data. And when you know about continuous data, try and have an understanding of interval scales and ratio scales. We've also talked about categorical data types. And in categorical data types, we see that there is one data type here, which is ordinal data. When you talk about ordinal data, when we break it further, at least when dealing with ordinal data, there is this that you need to know about ordinal data. For example, overall statement, poor to excellent. When we talk about ordinal data, there are some data that will be categorized from poor to excellent. There is agreement. There are some data that will be categorized from strongly agree to strongly disagree to strongly agree. And there are some data types that will be ranked. So when you talk about ordinal data, at least you should know in which category under ordinal data do they fall. Are they overall statements? Are they agreement? Or are they ranked? So that is that about ordinal data. At least this is what you should know when it comes to ordinal data under categorical data type. Now, other than that, we saw that you need to at least know about rectangular data. When we talk about rectangular data, we're talking about data that has been organized into rows and columns. For example, in pandas, data frame object in pandas is what we are talking about when we talk about rectangular data. And we know that when you talk about a typical frame, when we talk about rectangular data, that a typical frame of reference for any data analysis or any analysis in data science is rectangular data object. And you have given an example of a data frame when it comes to pandas, but also there are spreadsheets and there is also a database table. So these are the typical frames of reference for any analysis in data science that you should be able to have a clue about. But remember, when you talk about rectangular data, then that is a general term for a two-dimensional matrix with rows indicating records or cases and columns which indicate features or variable. And in Python, as we have mentioned, a data frame is the specific format when you talk about rectangular data. So at least you should have a clue on what rectangular data is. Now, again, another essential statistical concept that you should be aware of or that you should know are estimates of location. Now, these are statistical representation of central points of a data set. When you have a data set, there are central points of that data set. And estimates of location is something that is very key when it comes to any data analysis project or when it comes to data analysis. Now, an estimate of where most of the data is located or its central tendency is what we are talking about here when we talk about estimates of location. Now, under estimates of location, there are some things that at least you need to be aware of. These are things like mean, median, mode, and you find that these are some of the things that are basic maths. These are some of the things that are basic maths. And to learn about mean, median, mode, there are some resources that you have attached here where you can learn them as it loads. You need to know about mean, you need to know about median, and you need to know about mode. And some of the places whereby you can learn about these things are like Khan Academy, or you can learn from books, because one way of learning is from by watching videos, and you can also learn from books. And here when we talk about estimates of location, which are mean, median, mode, one resource here is the Khan Academy website. Like when you go to this link, it will talk about exploring one variable quantitative data summary statistics. And here you see they have handled mean, median, and mode. Median in histograms. There is a lot here. You can just come here and learn about estimates of location. Another place that you can learn this is this very good book called Practical Statistics for Data Scientists. It is written by Peter Bruce and Andrew Bruce. It's a very good book with some essential concepts for when it comes to practical statistics for data scientists. You can go to Amazon and get it from there. At now, it is selling at about $74.99. Another very good book. So those are some of the good resources which you can use to learn some of these concepts. There are many more than that, but these are some of the good ones. If you have any other that you think is good, put it down in the comment section below. So estimates of location, we have said that when we talk about estimates of location, we're talking about things like mean, median, and mode. And these are very basic, and at least at one point or another, you have met this. For example, we talk about mean. This is the sum of all divided by the number of values. So when we talk about mean, this is a basic definition of what mean is. That is the sum of all values divided by the number of values. And you have said that if in a list there are values, you get the sum of values in that list and you divide by the number of those values. Another name for mean is average. That is very basic, so at least you need to know about that. Other than mean, you need to know about median and you need to know about mode. And we talk about median, it is the value, is a centralmost value, or is a value such that one half of the data lies above and one data of the the other half of the data lies below. And another name for median is the 50th percentile. You need to know about these things, and that's why when you're beginning, we are saying that other than just knowing the essential concepts that are needed, essential statistical concepts that are needed for data analysis, that we were supposed to know some of the key terms, because these are some of the things that you will meet in your data analysis projects or in your data analysis job. So median, another name is the 50th percentile, and at least you need to also know why is median better than mean when it comes to measuring estimates of location. So these are some of the things that you need to be aware of, and that's why we are pointing them out. You need to know about mode. You need to know about mode. And remember, when you talk about mean, there are very many things about mean. There are things like trimmed mean. There are things like weighted medium. All these things you need to be aware of them when you are looking at the statistics that is essential for data analysis, or essential statistical concepts for data analysis. Now, another essential concept that you need to know about are estimates of variability. Estimates of variability. Now, when we talk about estimates of variability, you should understand which one to use and when to use it. You should understand which one to use and when to use it. When you talk about estimates of variability, you should understand which one to use and when to use it. And when you talk about estimates of variability, already we have talked about location, and location is just one of the dimensions when it comes to dealing with data, or when it comes to summarizing a feature. And you'll get that much of what we are doing falls under summary statistics. So go and find out about summary statistics. What is it? And as we have mentioned, location is just one of the dimensions when it comes to summarizing a feature. Now, and another dimension here is variability, or estimates of variability. And another name for this is dispersion, which measures where the data values are tightly clustered or spread out. When we say about dispersion, when we talk about dispersion, it measures where the data values are tightly clustered or spread out. So highlight that. You need to know about estimates of variability, and you need to know about dispersion. In this presentation, we are not learning about them. We were just highlighting on what you need to know. But in later presentations, we will go deep and even do code examples of this and do practical examples. But here, this is just a roadmap. So we have seen that you need to know about estimates of variability. Now, when we talk about this, here you need to know about standard deviation. Here you need to know about percentiles. Here you need to know about range. And here you need to know about variance. All these you need to know about them. Now, when we talk about standard deviation, here is another resource that you can use to learn about standard deviation. Again, it is from Khan Academy. As it loads, let us talk about percentiles. Now, important in summarizing data and checking the spread of data. When we talk about percentiles, it is important in summarizing data and checking the spread of data. Now, a resource that you can use to learn about standard deviation, again, you come to this link and Khan Academy. It is still loading. When it loads When it fully loads, we'll come back to it. Now here, it says calculating standard deviation step by step. Go through this. At least it takes you through what it means to what standard deviation is. So that's another resource. At least that's again another resource from Khan Academy. And you have mentioned Khan Academy and Practical Statistics for Data Scientists. And if you have any other good resource, put it, write it down there. Now we have said about percentiles. You need to know about percentiles. And talking about percentiles, there is this that you need to know about percentiles. You need to know about special percentiles. And when talk about special percentiles, you need to know about quartiles. And talk about quartiles, there is first quartile that you'll meet. For example, if you are working with pandas, when you draw a box plot, there is the first quartile, there is the second quartile, and there is the third quartile. Another name for them is lower or 25th percentile. There is median or 50th percentile. There is upper or 75th percentile. At least you should be well versed with this when it comes to essential statistics for data analysis. Other than that, you need to know about range. You need to know about range. And here when we talk about range, we're talking about things like the interquartile range, which we get by subtracting first quartile from the third quartile. That's why we have written here Q3 minus Q1. That is how we get the interquartile range. That is how we get the interquartile range. So at least you should know about that when it comes to estimates of variability, standard deviation, and these are square root of variance. At least you must have met these in your high school maths, or in any basic in your elementary school maths. You must have read about mean, median, mode, standard deviation. Maybe you must have also read about range, which is the difference between the largest and the smallest value in a data set. And we have also mentioned about percentile and the interquartile range, which is the difference between the 75th percentile and the 25th percentile. And as we have mentioned, that the 75th percentile is the third quartile and the 25th percentile is the first quartile, or Q1. So at least you need to know about those. You also need to know about variance. You need to know about variance. And we talk about variance, at least you need to know about population variance and sample variance. You need to know about population variance and sample variance. So that is that under estimates of variability. If there is anything else that someone needs to know, someone who is a data analyst or someone who is learning data analysis needs to know about estimates of variability, you can put it down in the comments. Another thing that we need to know about is data distribution. Another thing is data distribution. When we talk about data distribution, then here we are talking about its usefulness to explore how data has been distributed overall. We're talking about its usefulness when it comes to exploring how data has been distributed overall. Now, when we talk about exploring data distribution, what you need to know about this are box plots. Now, when we talk about box plots here, and before we go to box plots, each is good for graphing which data. You should know when we talk about data distribution, and here we are talking about when we're talking about making graphs, and talk about making graphs, you should know which graph is good for which data type, and you should know the difference between them, e.g. the difference between bar charts and histogram. So under data distribution, when we come to visualizing data, you should know which graph is good for which data type, and you should know the difference between them and when to use them, so that you don't confuse a histogram and a box plot, and when to use a box plot and when to use a histogram. So you should know about box plots, you should know about histograms, you should know about density plots and individual value plots. When you talk about box plots, you can break it further. You should know the difference between box plots and value plots. You should know how to find central tendencies using box plots, assess variability, identify outliers, very important, and compare groups. When you talk about box plot, at least try to learn this when it comes to a box plot. Then there is also histograms. When you are learning about histograms, at least try to understand how they are used to measure central tendency, used to measure variability, identify the shape of distribution, identify outliers, detecting multimodal distributions, identify subpopulations, and comparing distributions between groups. At least try and understand these. And there are lots of resources, good chunks of resources whereby you can learn all these. Some of these resources that you have mentioned here is just part of the resources that are there in the internet and in the online courses and in the mocks and in some of the videos that we shall be getting into at a later date, whereby we shall be teaching and writing code for these things that we are talking about. When talking about data distribution, you should also know about density plots and individual value plots, as at least you should know about such. Now, again, after having known about data distribution, you should also seek to understand how to explore categorical and binary data. You should also seek to understand how to explore binary and categorical data, And here we are talking about mode, expected value, bar charts, and pie charts. Talking about mode, expected value, bar charts, and pie charts. Another essential concept that is important when it comes to data analysis or statistics that is needed for data analysis is correlation. Another essential concept is correlation. And before we go into correlation, is that under exploring binary and categorical data, we have talked about mode, and the most commonly occurring category or value in data sets, that is mode. When talk about mode, it is the most commonly occurring category or value in a data set, and this you should have met in your elementary or high school math. When talk about bar charts, this is the frequency or proportion for each category plotted as bars. And there is also pie charts. You have at least at one point or another heard about pie charts, so you should have a knowledge of this. And you see, they are very basic but very important. You might think that they are very basic, but they are very important. Even if you don't know them to the detail, at least you should know these terms and how they work. It will be very important for you when it comes to data analysis. And when you start working with libraries like Panda, you will understand the importance of these things that we are saying. Now, another thing we have talked about is correlation. We have mentioned about correlation. And talk about correlation, we are talking about measuring the strength of the relationship between two variables. Measuring the strength of relationship between two variables. For example, you can use correlation is used to measure the relationship between height and weight. So you should know about correlation. At least you should know about correlation. And talk about correlation. When you talk about correlation, we have mentioned what it is, and under correlation, what do you need to know about under correlation? You need to know about scatter plots. You need to know about interpreting correlation coefficients. You need to know about interpreting correlation coefficients. Now here, when talk about interpreting correlation coefficients, here we are talking about talking about what is the strength of the correlation, what is the direction, and how do you interpret graphs for correlation, So basically, these are some of the basic statistical concepts that you need to know for data analysis, or the essential statistics for data analysis. And as we said, as we were beginning, that there is a lot that you need, that is needed when it comes to statistics. And some of the times, many are afraid that will I be able to master all these statistics for data analysis? But if you have a roadmap like this, at least it helps you know what you need. And as you have said in the other tutorials, that it's a marathon. It is not a sprint. So one day at a time, one essential concept at a time, you learn on the go. And by the end, even you'll be surprised at how much statistics you know for your data analysis project or for your data science projects. Now, we have tried to narrow down on the data analysis portion, because we know that when we talk about data science, data analysis is very important. The key idea of EDA is that the first and most important step in any project based on data is to look at the data. And by summarizing and visualizing the data, you can gain valuable intuition and understand the project. You can gain valuable intuition and understand data and understand the project. And when we talk about exploratory analysis, then we should understand that it is a cornerstone in any data science project. And that's why, in as much as we give data science insights, we have begun with the essential concepts or essential statistical concepts for data analysis, because data analysis is a cornerstone for any data science project. So basically, that is a rough idea of the essential statistical concepts that you need for data analysis. And at least now at the end of this, at least you have a clue. You have a clue on the statistics that you need for a data analysis, and you have a clue on the some of the key statistical terms for data analysis. So that has been our video today. You have a blessed day.